The last 5 videos you guys have watched were all about arithmetic sequences, where you have a common difference, you're adding to get to the next piece. Today we're going to start, or actually probably do all of, section 11.3, which is going to switch over and talk about geometric sequences and series. So we're basically going to do all of the same things that we did in the first section in 11.2, but this time we're going to do it with geometric. So it's going to be 1, a new formula, and 2, it's going to use this multiplication idea instead. So we're going to use this explicit formula. If you remember in the, I think the first video I gave you an explicit and an alternate. I don't even know why we have the alternate. We're not going to use it. You can get everything done with this explicit. So the explicit for geometric is a sub n equals a sub 1, so it starts the same way. But now here's where it's different. It's times r to the n minus 1. All right, we just got to figure out how that works. We'll use it for pretty much everything we're going to do. So let's start with an example. It says write an equation for the nth term of the geometric sequence. So we did that in the last section for arithmetic sequence. It's going to give me a second part to this problem, so it's basically 2 and 1. It says then find the 8th term. Okay, so I'm basically going to do 2 problems at once. Here's example A is going to give us this sequence, 0.5, comma 2, comma 8, comma 32, and dot, dot, dot. All right, start writing some things that you know. You should be able to find a sub 1 very quickly. So here's a sub 1. I don't know a sub n. I don't know what term they're talking about. And there's not a common difference like I did before, but there is a common ratio. That's where we divide them. If you want, do 2 divided by 0.5. I think it's easier to do 8 divided by 2 and find out that that's times 4 for everything. So I should have all the pieces I need just to plug this right in. The formula again was a sub n equals a sub 1, so that'll be 0.5, times r, and when they do this they usually put it in parentheses like this. So it's times r to the n minus 1. And unless you tell me what n you want, that's as good as I can do. There's nothing to do. There's no distributive property, anything else. Now, I said unless you tell me which one you want. They want a sub 8, don't they? They want the 8th term. And so I'm going to find a sub 8 by doing 0.5 times 4 to the 8 minus 1, because that's my n. That would be 0.5 times 4 to the 7th. Use your calculator, figure that out. If you type all that in, you're going to end up getting 8,192. And that is the 8th term. That should signal right away something that's different with geometric. Arithmetic grows slowly. It's like slope. It's not changing much. Geometric, if you remember when I showed you in the first section, it grows exponentially. So starting with 1/2 for the first term, a sub 1, within 7 more terms, by the time I get to a sub 8, we're already in the 8,000 range, and it just grows faster and faster as we go. All right, so you're going to get a lot of big answers. Here's B. B gives me a sub 4 equals 5, and it gives me r equals 6. Okay, it didn't give me a sub 1, but I know this formula. I'm going to write it down again. A sub n equals a sub 1 times r to the n minus 1. So let's see what we know. I guess I know in a sub n, we're talking about this guy right here. It'd be the 5 here. It's the 4th term. It'd be the number 5. I don't know a sub 1. R is 6, so we'll put 6 in parentheses here. And the n that I use to get this 5 over here is that 4, and so the 4 is going to go in right here, so it'll be 4 minus 1. 5 equals a sub 1 and 6 to the 3rd. 6 to the third is 216. So I'm going to call it 5 equals 216 a sub 1. Kind of weird. Divide by 216 and you're going to get 5 over 216. Kind of an ugly, weird, small answer, but that's okay. Also, though, that's not what they were asking for. What they were asking for is the equation. So I have to go back up and rewrite this equation now. It's going to be a sub n. We're not just talking about the fourth term. It's all of the terms, any term you want. The a sub n is going to be 5 over 216. The r still stays as 6 in parentheses, and now we don't know which term we're talking about, and so we're going to say n minus 1. And that's the formula for it. But remember what they asked for. They asked for the 8th term also. If I go back up here, they wanted to find the 8th term. So let's plug that in for our n. So it'd be a sub 8 equals 5 over 216. See if I can get that right. And then 6 to the 8 minus 1. All right, so that means what? 5 over 216 and 6 to the 7th. I would just type that in. When you do 6 to the 7th power, right, you type in 6 and then caret 7, you're going to get 279,936. And then you have to take it times 5 over 216, and it just turns out to be 6,480. So again, here's another one where by the 8th term, it's in the thousands, and it started with some weird small fraction. Okay, those are the two basic types. Let's talk geometric means now. So this example says, find the 3 geometric means between, leave it up here, between 2 and 1,250. Okay, geometric means, the word means in these is talking about the missing pieces. Remember we had arithmetic means, there were the missing pieces in the middle. This time it's geometric means, they're the missing pieces in the middle. My formula, a sub n equals a sub 1 and r to the n minus 1, I need to fill this stuff in. Well, I know a sub 1's right here. That's the first piece. There are 3 missing pieces, and then another piece, this 1250, that would be like my a sub n. And what n is that? Let's see, I used the number 2. There were 3 missing pieces. That's 4 things now. This is the 5th term. This is really a sub 5, which means n is equal to 5. Okay, let's plug it all in. A sub n, that's that last piece we know, 1,250, equals a sub 1. That's 2. I don't know the r. I don't know how they're getting there, so we'll leave the r like it is. And then our n is 5, so it's going to be 5 minus 1. All right, let's start filling this out. That's kind of weird. 1,250 equals 2 to the n times r to the 4th. I guess I can divide by 2. And when you divide by 2, you're going to get 625 is equal to r to the 4th. Now, I don't know if you've ever been shown how to do r to the 4th or to undo it. If I go over here to the right real quick, you know that when it was r squared, that we would take the square root of both sides and these would cancel out. All right, when it's r to the 4th, we do something very, very similar. You take the 4th root, though, and you put a little 4 right down in here. And so that 4th root and the 4 will cancel out. And when you do it on the other side, so let me do that real quick. I'll put the 4th root over this and the 4th root over here. Let me erase these guys. What that is saying is, on the 625, what number can I use 4 times in a row to get to 625? Couple things before I get to that answer I'll show you is that we know that the right side is just going to cancel out and become r equals. Just like with your square roots, you had to put a plus or minus. If it's an even root, like a 4th root, there needs to be a plus or minus here also. And here's how you're going to type it into your calculator. I'll write it here to the right. Type in 625, use the caret button for to the, and if you want a fourth root, it's 1/4. So type in 625 to the 1/4 and see what it gives you. I got 5. All right, so that means that that's what we're going to multiply times to get to our next pieces. So where did I start again? Oh, it was the number 2. And then there were 3 geometric means, and then the number 1,250. Now here's a slight problem though. My R says plus or minus 5. So I have to do it once for positive 5, and I'm going to have to do it again for negative 5 because there's 2 possibilities of the way to do this. So I'm going to write it down twice, and let's fill these in. If I used 5 on the top row, 2 times 5 is going to give me 10. Times 5 is going to give me 50. Times 5 is going to give me 250. And if you take that times 5 again, you'll get 1,250. On the bottom, take it times negative 5. 2 times negative 5 is negative 10. Times negative 5 is positive 50. Times negative 5 is negative 250. And then times negative 5 again is going to be positive 1,250. So I have found the 3 geometric means, and actually there were 2 sets of them. There were 2 different ways to do it because it was an even root. Okay, that's new enough that I think we need to do one more problem like that, and then I will end this video and we'll do another one for sums. So the example here says find the 4 geometric means between 0.5 and 512. Okay, if I start with kind of the end in mind, I know that I'm going to have this 0.5, and there are 1, 2, 3, and 4 missing pieces, and then it will give me the number 512, and I just have to find out what pieces go in there. I'm going to do that with my formula. A sub n equals a sub 1 and r to the n minus 1. A sub 1's 0.5. A sub n is 512, and look over here to the right, it's actually the 1, 2, 3, 4, 5, 6th piece, right? Which means that n is going to equal 6. Okay, if I plug this stuff in now, a sub n is going to be 512 equals 0.5. I don't know r, and this time it is to the 6 minus 1. Okay, so it's 512, it's 0.5 r to the 5th. Let's divide by 0.5. And when you do that, you're going to get 1,024 equals r to the 5th. Now here's the spot where we have to do that weird square root thing. Last time we did a 4th root. This time, because it's to the 5th power, we will do a 5th root. You just have to cancel out whatever's there. Important detail here, we had a plus or minus on the last one because it was an even root. A 5th root does not need a plus or minus. And so there's only going to be one set of answers here. It'll be r equals, I'll write it over here to the right, do 1024 raised to the, and we're doing 1/5 power. If you type that into your calculator, you hit enter, you will get the answer of 4. So that just means my r is 4. I can go all the way back up here to the beginning thing that I had, plug my 4 in, or multiply by 4, and 0.5 times 4 is going to give you 2, times 4 is going to give you 8, times 4 is going to give you 32, and times 4 is going to give you 128. If you take 128 times 4, it gives you 512, and I have now found the 4 geometric means between there. Let me say that one more time. I only had one set of answers here because it was to the 5th root, and I had 2 sets of answers here because it was to the 4th root, and I had to put a plus or minus. So that'll be an important detail. All right, that's the end of this one. We're going to do partial sums in the next video, but this should get you halfway through your homework assignment.